Hey guys, today we're going to talk about a method called completing the square and how we can use this in solving some quadratic equations. But first off, we're just going to define and talk about what completing the square is. Now in those slides that you might be following along with, we have this trinomial and we are asked find the value of c that makes this trinomial a perfect square. So you can go ahead and play around with some numbers and try to figure out what's going to make this a perfect square. I happen to know, and because I know what completing the square is, that this value of c has to be 25 to make this a perfect square. Which means that we could take this trinomial, and we can factor it down and write it like this. You can write it as x plus 5 squared. What we're really going to look into now is what relationship exists between the b and the c if it's a perfect square. And if you think about having the 10, in order to figure out what c was, what you could do, and this is what we're going to be using today, is you can take half of the b, so half of 10, which is 5, and square that. So half the b squared is equal to your c. So half the b squared is going to be equal to c. That's what will make this a perfect square trinomial. And to generalize it, not even having numbers in here, if we have x squared plus bx, and we'll say plus c, and we want to figure out what value c will make this a perfect square, it's going to be your b divided by 2. So half of your b squared will equal your c. This will create a perfect square, and our a is equal to 1 here. So this will create a perfect square. And we're going to use this in solving some equations. But first, let's just do a couple of practice problems of given different trinomials, can we create it to be a perfect square? So let's go ahead. Our first one says x squared plus 6x, and we have a plus c for now, and we want to make this a perfect square trinomial. What value of c will result in this being a perfect square trinomial? Well, half of b is 3, so b over 2 is 6 over 2, which is 3. So 3 squared, we'd have to add 9 to this. So x squared plus 6x plus 9, this would end up being a perfect square trinomial, and we could then, and we're going to want to write it like this in the future, write it as x plus 3 squared. So when you write it as a binomial squared, then you're going to take half of the b term. That's going to be what goes inside the binomial. Because when you square this, you'll end up with the 9. You'll end up with 2 3x's. That'll become 6x's. At our last one, before we start solving equations with this method, we have r squared minus 8r plus c. We want to know what value of c makes this a perfect square trinomial. So take half of your b and square it. So half of this is -4. When you square -4, you get 16. So if c is 16 here, that makes this a perfect square trinomial, in which case we could factor down to r. We're going to have a minus, but minus half of your b, which is 4. So r minus 4 squared. Perfect square trinomial. This is how we're going to want to write it when solving. Okay, so let's see how we can use this to solve different equations. Right now, one of our main methods to use is factoring, and all completing the square is a different method to approach some problems. Sometimes factoring won't work, and then you might have to fall back on completing the square. So when you are completing the square, you're going to want to isolate in the equation. You're going to want to make it so it's x squared plus or minus bx on one side, and then equal to some number over here on the right side. You're going to want to set it up like this. That's going to be the goal. And we also want to make sure our a is equal to 1, but all the ones we work with for now will have an a equal to 1. So we're going to want to set it up like this. We'll just say it's equal to a number, we'll just say d. And then once you're here, you're going to want to complete the square. You're going to want to turn this side into a perfect square by doing that half of b squared. That was like your c. And then you'll have to add this to both sides though. You'll have to add the half b squared to both sides. And then this will be really nicely written as x plus that half of b that goes in there. And then over here, everything will combine together to just be some number, and then you can take the square roots of both sides, like we talked about that square root property, and solve. So this will be the method we go through. So let's start off with the equation x squared minus 6x plus 12 is equal to 19. And we want to use this with completing the square. Now you could try to move everything over and use the zero product property and factor, but we're going to use completing the square so we can get familiar with this method. So we want to try to isolate your x squared. In this case it's minus bx, which means we're going to have to subtract 12 from both sides. So subtract 12 from both sides, you end up with a 7 over here. Now the whole process of completing the square is going to turn this into a perfect square. To do that, you're going to take half of your b, so half of 6 is minus 3, and you're going to square it, so you're going to end up with plus 9. That would be your half of 6 is negative 3, and you're going to square that. That's where the 9 comes from. If you add 9 to the left side, you have to add 9 to the right side. Properties of equality. So 7 plus 9 is 16. On the left side, the whole purpose of completing the square is so that we can write this as x, and it's going to be minus 3 all squared. If you were to square this out, you'll end up over here. So now we have x minus 3 squared, and then equals 16. So this whole quantity is squared. We can take the square root, and we're left with x minus 3. Over here on the right, we'll take the square root of 16, which I hope we get as plus or minus 4. So that means we have two cases here. X minus 3 can be positive 4, or x minus 3 can be negative 4. So let's say we work with x minus 3 equals positive 4, then x would equal 7. Or you have the possibility of x minus 3 equals negative 4, in which case x would equal negative 1. So your solutions here are negative 1 and 7. And just like that, we're all done. So completing the square, you're going to want to set it up so you have a perfect square, so then you can take square roots. That's the whole purpose of it. Tricky thing is making sure you have the right term added to both sides. Let's look at our next problem. So our next one, we have x squared minus 12x plus 3 equals 16. And again, you might be able to use factoring to solve this as well, but we want to become familiar with completing the square because it'll work even when you can't factor. Sometimes factoring won't work. So we want to set it up so we have x squared minus our bx on the left, and we're going to go ahead and bring this 3 over, subtract 3, will be equal to 13 here. Now let's go ahead and complete the square on the left side. So x squared minus 12x. To complete the square, you're going to take half of the 12, so it's negative 6 squared, that's plus 36. So you add 36 to the left, you have to add 36 to the right. When you add 36, you should get 49. Over here, we can turn this into x. Well, half of the b was 6, so minus 6, all squared. Now we can take the square root of both sides, so you'll end up with x minus 6 equals plus or minus 7. So we have two cases. X minus 6 is equal to 7, in which case x equals 13. Or you have x minus 6 equals negative 7, in which case x equals negative 1. So your solutions here are negative 1 and 13. That would solve this equation. Alright, on to our last one of the day before you can practice some of these on your own. We have x squared plus 14x minus 51 equals 0. So we're going to try to do this by completing the square. So first step, we want to isolate. Get your x squared plus bx on one side, move everything else to the other side. So so equal to that constant of 51. Now we're going to go through the process of completing the square. Take half of your b, which is 7, square it, which is 49. So you're adding 49 to both sides. 51 plus 49, we should end up with 100 over there. Over here we completed the square, so now we can write it as x. You have a positive, so plus half of that b was 7. So this is what we have now. We have perfect squares on both sides. We can take the square roots. So we'll end up with x plus 7 equals plus or minus 10, which gives us two scenarios. X plus 7 equals 10, in which case x equals 3. Or x plus 7 equals negative 10, in which case x equals negative 17. So our solutions are negative 17 and 3. And again, we might be able to use factoring for these. Actually, the ones we did today, we could have used factoring. Tomorrow we'll talk about scenarios where we have to use completing the square because factoring won't work. So this will be a really good method to know for those problems. For now, just practice some that work out with really nice numbers. In the future, we'll talk about some that don't have or numbers that are so nice. Alright guys, have a good day.